Hello everyone. This is our second session with the survey drafting techniques. In this session we'll be talking about very important concept, the concept of bearing. Bearing is the engineering method that we use to describe the direction of linear segments. Segments such as it could be the segment of a road, the center line of that road, or a segment of a pipeline, or a retaining wall, boundary. All of those linear components. So it's great to say the road is 1 kilometer long, but we need to know at what direction that 1 kilometer length. Now the bearing concept uses north as starting point, and from north we start measuring a bearing angle, what we call it, clockwise. So if you can see there's a line here. For example, if I draw a line, let's say this is the starting point. It's always going to start from here. It's always the center of the coordinates here is our starting points. So from this starting point, if I draw a line that way, by specifying this particular angle, what we call it our bearing angle, let's call it theta for now. By specifying the angle theta, that will say this is the length or the center line of the road. And now by knowing how much the length of that road, for example from here to there, say it's 100 kilometers or wherever, that will specify exactly the starting point and the end point of that road. Because by specifying the length only, this road could be starting from this point here, but could be ending at any of these points with the same length. So this is as a quick overall view. Let's go into details of how do we deal with bearing and why do we use bearing and how we are going to utilize it in practical examples. So the information usually we deal with from our point of view as engineers or designers, we always get the survey information. The surveyor on site will be doing the work for specifying the starting point and the end point of a linear segment and specifying the bearing angle and the length and send us that information. So our job, if we have this information, how can we describe this information on the plan, or how can we draw it in very simple terms? So to be able to understand that, we have to understand what's the meaning behind it, because it's crucial. It's very important that we do understand that. So when we look at it, we know if it is correct or there is something that we have to correct, reverse, or describe in a slightly different way. We will talk about them in a minute. Let's set some foundation. The main concept, our north, which is always facing up in most cases unless we show otherwise. If north direction or orientation is not shown, that means north is facing up. Okay, so let's use our north. Agree, this is our starting point for measuring any angle. Second rule, the measurement will be clockwise. There's no measurement the other way around. We don't go counterclockwise or the opposite direction of the clockwise. Number 3 is the unit. Units we use for bearing called degrees, minutes, and seconds. That's for the polar coordinates. Degrees, minutes, and seconds, it's a different way of describing just the angle units. That will give us a bit more accuracy in terms of the value. I'll be expanding or talking a bit more about the bearing as we go further, but let's start with the foundation. As we agreed, number 1, north is our starting point. We're moving clockwise or we're rotating clockwise. So again, if I draw any line here, what we are measuring clockwise. If this is our starting point always, I do not measure the other way around. Okay, we don't do that. That's incorrect. Always the measurement is clockwise. Number 3, the unit, as we agreed, is degrees, usually 2 degrees or 2 decimal digits. And then minutes, again 2 decimal digits, and then seconds. Okay, we usually refer to minutes like that and seconds like that. There we go, guys. So you have it if that's our bearing at north, anything within the first quadrant, the first quarter of that circle, that will be between 0 and 90. So if I describe any bearing angle between 0 and 90, I should straight away, the minute I say the bearing angle is, let's say, 65, I should be straight away imagining a line starting from here and moving there. I'm imagining in my head an angle between these two lines of 65 degrees, or degrees, and say 30 minutes and 10 seconds. I'll talk about the unit in a minute. The important part that we understand, anything within this area here, it's between 0 and 90. Anything in the second quadrant should be between 90 and 180. Third quadrant should be between 180 and 270, increments of 90 degrees. And the fourth quadrant, that will be 270 and 360. 360, again, it's the same as 0. So this point here representing the 0 or 360. Both of them are correct. This is very important to start with, guys, that we realize the minute we read the bearing value, at what quadrant we should be drawing our line. I should be straight away imagining straight away a line starting always. That's our starting point. That's the start of the line. Okay? The starting point of the line always from the center and goes out in any direction. So if I say anything, let's say 105 degrees, I should be straight away imagining a line doing this in the second quadrant, because that's between 90 and 180. In fact, to be more precise, should be a bit closer to the 90, something like that. This is the starting point and that's the end point. Very important to realize that, because when we specify bearing or bearing angle, it's not only just telling us the shape of the line, which is, or the inclination of the line, what you can see here, because it's telling us starting point, that's our starting point, and an end point, because I can draw exactly the same line but in the opposite direction. Keep that in mind. Look at these two lines, but if that was the starting point, that means it's in the fourth quadrant in here. That means the bearing angle here should be between 270 and 360. Why do we use this? Let me just show you a quick practical example before I expand a bit more on the details for this, so you can visualize while we're learning this. Just I'm opening an example of land title certificate, what we call it, which is you do have it on your learn page. You have this file in your learn page. So what these certificates are, usually any block of land for a home, a large industrial project, commercial, a new subdivision, you name it, any land does have what we call it land title certificate. That has two main numbers, the volume and the folio. These two numbers that will describe exactly the location of the land. Okay? Regardless of that, the important part for us here to learn that any land title certificate should have a small map like this. And that map, it's the only legal form that shows the exact size of that land. So as you can see, shows the what we call it allotment number, the number here 198, shows the area, and that area most of the times in meters squared. Sometimes we have them in the old land titles in hectares or acres or different units, but mainly our work will be in meters square, and will show us the boundary of that land. As you can see here on the boundary, it does show you the value of the length of that boundary, which is 30 meters. Great, that's the unit here thing, meters. So it shows you that's 30 meters, but also it shows you the angle of that line, 1790 degrees 36 minutes. I'll talk about the units in a second, so don't be too concerned about minutes, seconds, and all of those. They are very easy. But as a concept, that is telling me this line here is 170 degrees from the vertical line of the north. That's the north line, okay? So if I measure from that north, 179, which is almost 180 degrees, and I draw a 30-meter long line, that will be exactly where the boundary line is. That's why it's very important to us. So in something simple like this, that's easy really. You find that you don't need all of this information. It's just a rectangular shape with 18 meters wide and 30 meters long. Great, easy. But what about a bit more complicated land, like this, for example, a block of land I was working on recently. This is the block of land that we're working on, and we have to draw, as a starting point, we have to show the boundaries of that land. So if I need to show the boundaries of that land, and as you can see, there's nothing uniform about this boundary, there's nothing rectangular or easy shape to draw, we have to utilize these numbers accurately in order to draw these boundaries accurately. Okay, so this is the importance of bearing. It's very important concept that we have to learn how to use and utilize, so we can start with our plans accurately. Okay, so the point we can take from here, each segment, as you can see, this boundary is made of different segments. When I'm saying segments, usually we refer to straight lines as segments. Simple as that. So each one of these segments has two components, length and bearing angle. The bearing angle describes if I take from north, from that direction there, an angle of 173 degrees, 1 minute and 20 seconds, I'll be drawing that line accurately, and the length of that line I should be drawing 363 meters and 12 centimeters, for example. Now, let's go back to our description here. How do we utilize this and understand it correctly? Number one, we agreed. The circle, obviously it's 360 degrees. Any circle is made of 360 degrees. That 360 degrees divided into 4 quadrants. Each one is 90 degrees. Our starting point for any line is the center. This is the center point here. Okay? That means any line, if I describe the length of that line and the angle with that north, I can accurately describe where that line is sitting. In terms of the units, which is, we said we will talk about it in a minute, very easy. Degrees, minutes and seconds, it's used rather than saying, for example, 30.00351 degrees, which is, it could carry on lots of mistakes if we do that. What we usually describe the degrees in degrees, minutes and seconds. What is it equivalent to? Simply each 1 degree, there we go, just get that, okay, each 1 degree is 60 minutes, shouldn't be hard really, it's exactly the same as the time. So as we have each 1 hour is 60 minutes, each 1 minute is 60 seconds, we have it exactly the same, but rather than the hour we use degrees. So each 1 degree equals to 60 minutes. Each 1 minute equals to 60 seconds. This will give us 1 degree equals to 3,600 seconds. Simple as that. So in order to describe a angle, bearing angle, what we call it, in the polar coordinates. By the way, what we're using here, what we call it, polar coordinates. I'll show you that in a second. The polar coordinates, there we go, right here. So these are polar coordinates. Okay? Because in a minute we'll be talking about rectangular coordinates, slightly different. This is polar, measured to the north point. Okay? That's our north, usually we specify. How do we convert between, in terms of units, how do we convert between numerical degrees or angles to degrees, minutes and seconds? You can do it manually based on this understanding. You can calculate all of that. Or if you do have, which is you should, and that will be very useful, a scientific calculator. And if you don't, and you're planning on buying one, I would recommend buying the Casio, because I'll be doing all my lectures on this one, so you can do exactly the same thing. If you have a different calculator, please Google it on how to do the same process as what we're doing here. Let's go back. So for example, if I have an angle of 60 degrees, let's use one of these examples that we were looking at a minute ago. So let's go to this one, for example. Let's choose something a bit random. Let's use that one, 265, 44, 40. So how can I describe that in a numerical value? There's two ways of doing it. The basic ways, which is I wouldn't recommend doing, 265 plus 44 divided by 60. You can do it on any calculator, plus you don't need a scientific calculator, plus the last one, what we have, 40 obviously divided by 3,600, because I'm converting all of them to degrees, and that will give me my numerical value, which is 272. That is not correct, you see, so that's 44, not 440. Okay, you see, that's very important. As I said before, without this knowledge, without understanding the knowledge, I'm using a tool. This could be a software. I'm using a calculator here, which is a tool, basically the same as any software. If I don't have the knowledge behind it, I would have accepted the answer it gave me a minute ago without knowing what's going on. But because I have the knowledge, I know I've got 265 and I've got a components of degrees and minutes. That shouldn't be altogether be more than 265 at the end. It will be 265 point something. It can't be 270 something what we got as an answer. Okay? So 265, 44 divided by 60, 40 divided by 33,600, and that will give us, again, there we go, that's much better now, 265.74444. That's one way of doing it. Or the easier way, I can say 265, and just by using this button here, once, that means it's in degrees, then 44, I'll press it again, minutes, and then 40 seconds. I'll say equal, and that gave me the answer. I can just click on that to change the answer to the format that I'm looking for. Okay? So I have to enter it first, press equal, and then click maybe once or twice on that button here, which is usually change the form of your answer, and that will give me the exact answer. Now, if we are going to, or we need to convert the other way around, if we have, for example, 260, let's choose different than 60, so let's say 145.332 degrees, how can I change that to degrees, minutes and seconds? The easy way, if you have the scientific calculator, by just click equal, and that will give me this form here, and by just clicking once on this button, that will give me exactly what it should be in degrees, minutes and seconds. So there'll be 145, 19 minutes and 55.2 seconds. If you don't have the scientific calculator and you need to do it manually, what you have, there we go, I still have, so 145.332. What we have to do for that number, first of all, we say, rather than for 145.332, we say 145 plus, then I've got, actually I have to do it step by step, so 0.332 divided by 60, and that will give me an answer. 0.332 not divided, type multiplied by 60, and that will give me an answer. That will be 19.92. I'll be taking the 19 and I'll take those to calculate the seconds, so that will be 19. I just multiplied the fraction of that number, what we had, the decimal digits, multiplied by how many minutes. That gave me 19 minutes, and then I will use this number again to calculate the seconds, and that will be 0.9 0.92. So I know that now I've got 145, 19 minutes, and then 0.92 times 60, not times 60, times 3,600. Actually, no, times 60 again. And that will give me 55.2, what we had before. Okay, so my number again now I can put it all together: 145 degrees, 19 minutes, and 55.2 seconds. It's longer, as I said. That's why I don't really do that, and there's larger margin for error. This is the easier way of finding that. Or you can set up a quick Excel sheet from what you learned before, how to do this. So it's up to you. But the important part and the easier part of it that we know, at least if you have, most of the times you have to convert rather than from a numerical value to degrees, minutes, and seconds. What we usually have to do is the other way around, which is what you see here. Usually we get a number, which is, you can do it on a normal calculator. You don't need really a scientific calculator. If I have a number like this, for example, let's take a second example, and I need to convert this angle into numerical value. Again, I'll put 177 plus, I've got 19 divided by 60 plus 30 divided by 3,600. That will give me an answer directly, 177.325. Or we can do it the other way around again. I'll do it 177 and I'll enter that, 19, that, 30 again, equal, and press on that. That will give me the exact number. So that's in terms of units conversion. You'll get one question about this in your quiz, so you better learn how to do that, please. Converting between degrees, minutes, and seconds to numerical values. Okay, so I may ask, what is the numerical value of a certain angle? Now, knowing this, knowing the units, knowing how to use the calculator to do that, you've got them here. Okay, let's start taking some examples on that and just reinforce the understanding. Let me just go here just to reiterate on what we discussed. Simply, as we agreed, always, unless specified otherwise, north will be facing up, vertical facing up. This is our north point. That's the standard that we work with for engineering drawings. Why do we need to use bearing? As you've seen it on the boundary, I've got a series of lines. These lines, they could be in any direction. Okay, each one has a length, easy to draw a line with a certain length, but what would be the direction of that line? I keep saying direction, not angle, because it's very important for you to understand, guys, that when we specify bearing, we're not specifying only the angle. I'm not specifying just that or that as an angle. Because we have our convention that we are starting from north, moving clockwise, that will give us a direction, not only an angle. So the angle has a specific direction, clockwise measurement. So when I'm saying an angle of 60 degrees, that means I'm starting from a point and moving at a 60 degrees from our imaginary line here, at that point, starting point, imaginary line representing north, and I'm measuring from that line 60 degrees clockwise. So my line must be like that. Okay, it can't be like this, 60 degrees here. That's incorrect. Okay, so that's not the case. Our line should be here, 60 degrees. Okay. Why this is important to us? Because let's go back to the same boundary line. When I'm drawing, and we'll see in a minute how to draw something like that on the software. When I'm drawing a boundary like this, each one of these lines, when I'm reading the bearing angle, I should be evaluating, is that the correct angle or is it the reverse angle? For example, let's look at this line here. Okay, actually let's look at this line. This line at 177.19. So when I'm reading this number, regardless of regardless of the values here, I'm just straight away, regardless of the length, I'm imagining this is north, facing up. And usually we read where north is. It's shown usually in most plans. They show you where north is. Okay, so that's north. Okay, so when I'm reading this number, that means I'm imagining a line going from that number 177, almost 180, and then drawn here. That's great. That means this is the start and this is the end of that line. That's correct. That's in line with what I've got here. This is the starting point and this is the end point. Why this is important? Because in the surveyor, where did we get these numbers from to start with? We got these numbers when the surveyor was on site. He was putting his tool in one point, measuring to the other point a length and a bearing angle. So that means it's telling me that the surveyor has the tool here and was measuring to that point there. Okay? So the direction is from this point to that point. It's important to know that because when I get to this line, for example, here, this 265, that's all good. 335, that's all good. All right, so let's say the surveyor was moving along these lines. That's all great until I get to this point here. It looks like I'm reading, that point is correct, sorry. That's the bearing angle here. Until I get to this point here. So we got to this point. If the surveyor was here and measuring that line, I should be, again, without reading the value here, without reading this value, I should be imagining a line like this, and that's the starting point. So this angle here, it's always, by the way, the bearing angle, as we agreed, it's always with the north. This angle here should be between 90 and 0. So that's the limit of it. It's in the first quadrant. But what I'm seeing here, this angle is way different. This means if I use this number blindly, without thinking through it, without understanding the concept, and I enter these values on the software, when you see in a minute, the software simply will draw a line like this, rather than like that, which is incorrect. So it's important to understand when you look at this number here, you should evaluate what should be the value for this number. I'm looking at the line here. If this is the starting point and this is the end point in my work, that means this line here should be between 0 and 90. If not, I find that it's not like that. What we have to do, what we call it reverse bearing. That means it's not wrong. That doesn't mean it's wrong. What happens here, guys? Simply, for this particular line, it looks like the surveyor started from, for a reason or another, maybe for the first day they finished all of those, they left for that day, they came the next day, they started on these lines here. But for this particular line, he measured from this as a starting point, and that's the direction, this is the end point. As long as I realize they are not, this line and that line are not the same direction, I'm all good. Because simply all what I have to do, there's a rule about this, for the reverse bearing, I can either draw from here to there on the software, or if I want to draw from here, all I have to do reverse the bearing. And reversing bearing is very simple rule. Anything more than 180 degrees, we deduct 180. Anything less than 180 degrees, we add 180. I'll talk about this in a minute. Let's not complicate the matter now. Forget all of this. This is all just to highlight that understanding bearing is important. When I'm reading an angle, when I'm reading the value of an angle, that's what I'm trying to tell you. When I'm reading the value of the bearing that I have, for example, if I'm reading 175 degrees, 30 minutes and 33 seconds, when I'm reading that, that means I should be imagining line in a certain quadrant. So I straight away in my mind I'm drawing that and I'm saying this is north. I'm doing all of this quickly in my mind, and I'm saying my line should be starting from a point like this and going something like that, roughly. Okay. All right. Hopefully this is clear. Just the rules are very simple. Number one, north is always vertical, facing up. Number two, the rotation is always clockwise for these angles. Number three, our bearing angle is always measured between the line that we are trying to draw or illustrate on our plans, and the northing point, or the northing point. Yeah. Okay. This is our bearing angle, what we call it. Okay. So this is what we are specifying here, or what we're showing here. So the movement is always clockwise. Always imagine that you've got 4 quadrants: north, east, south, west. And any line with any bearing angle, we should roughly know at what quadrant does it sit. These are some examples. That's the first quadrant. What the angle they should be between 0 and 90. The second quadrant, it should be between 90 and 180. The third quadrant between 180 and 270, and 270 and 0, or 270 or 3 and 360. That's the fourth quadrant. Why it's important, as I showed you a minute ago, for specifying side boundaries, for specifying the road center line. So this doesn't have to be really an enclosed line like this, what you're seeing as a boundary lines. It could be an open line specifying the center line of the road. That's also usually described in a bearing components, and we will see when we design our roads, we will show these bearing values. Reverse bearing, I'll talk about it just to show you. This is, for example, a center line for a road. We call it open traverse. Okay, so we have 2 types of traverses: closed traverses and open traverses. So this is an open traverse, and that's a closed traverse, like the boundaries. Okay, so this could be representing a road, could be representing a center line of a pipe, any of these linear components. Reverse bearing, I'll go back to this in a minute. Let's take our knowledge, what we learned so far, and utilize it on Civil 3D to draw a boundary. Let's use this boundary, for example. How do we describe bearing? Or when I was saying I was working on one of these sites not long time ago, let's say that you are required to as a starting point to draw the boundary of this property. Okay, could be for industrial project, for residential project, doesn't matter. Okay, this is the properties. Let's see how can we draw this on Civil 3D, or AutoCAD would be similar approach. So let's go to Civil 3D. We've got a few main settings that we have to fix first before we start doing any drawings. We have to make sure that we've got the right settings. Every time I'm opening Civil 3D, on purpose, for me, I'm opening a new file. You shouldn't, or you don't have to do that. You can always open your existing file, what we agreed that you should fix the units on that file, but I'm doing this again and again so I can just make you very fluent or very quick at fixing your units to start with. So as usual, the first thing we do, check our units. And now you understood few extra components, that our angle, we are using degrees, minutes and seconds, and this is the precision. We are measuring to the nearest second, so we're not taking decimal digits for seconds, or we're not stopping at minutes. So this is where the precision that we're looking for, degrees, minutes and seconds. Our direction is clockwise always. We're using as a length unit is meters, and for the direction we're using our north as starting point, as we agreed. If I click OK on those, now in order to use the software correctly, there are a few other things I need you to check, please. So if you don't have the dynamics input here, this button here, first of all, turn it on. If it was off, if it was like that, turn it on. And if you don't have it, if you go to the right hand corner here, you've got your dynamic. Where is it? There we go, dynamic input. That is just simply to show you the values that you're entering. Simple as that, just so you can see them on the screen while you're entering the values for these points that we will be entering in a minute. Okay, so after you do that and you show it here, please right click on it so we can go to the settings. On the settings, if you have this ticked, please untick it. That will create some mistakes, so it's important that this is unticked. I don't want other dimensions. All what I'm looking for is just the point input. Okay, and on the settings here, I need the polar format and relative coordinates. Okay, so the polar format and relative coordinates. It's important that you have the first two options clicked. Let's go OK. So let's say that our task was, I'm not going to ask you now to draw this large, let's draw this smaller one. So let's just take this, copy, I'll enter it here. Again, remember how to enter photos, or just I'll paste it for now, just an easier way. Okay, this is pasted here. I'll move it in a second. This gave me, I'm saying okay, it doesn't matter, it's just as a guideline, so I don't have to switch between screens. I'll have another screen here on the side, but I just want to put it here so you can see where I'm getting my values. Okay, one last thing, please show the grid so you can see where the 0 point is. Okay, I need to start from point 1 here. We need to start from any of these points really, but I was just choose point 1, what's specified here, 1, 2, 3, 4, 5, 6, 7. So I'll start from point 1, and I want point 1 to be starting from the 0 coordinates here. Okay, so in order to do that, first of all, to draw this, I need to choose a polyline as a starting point. Later on that polyline, we can change it to alignment, we can change it to boundaries, anything that we want. Okay, but as a starting point, as a polyline, easier to work with. So I chose the command for polyline, the same as an AutoCAD command. And to start from 0, this is, by the way, can you see these numbers here? They appeared on the screen. That's when I turn the dynamic input. So if I turn this one off, you can't see these numbers. So these are just simply, as I said, to show you the coordinates that we'll be working with. Let's start with the first point. I'll show you in a minute what these numbers are representing. Okay. To start from 0, 0, all I have to say 0, that symbol, which is where is it, the symbol here, you see it in a minute, and 0 again. Just do that, look at them here. 0, the symbol of less than. Okay, so on your, let me just turn on the keyboard to show you what that is. So on your keyboard, this is the symbol, which is shift and that. Okay, shift and comma, that will give you less than. Okay, it's very important. Or what you could have done, let's stick with that. It's easier to do it this way. I'm not going to show you too many options for now. Okay, so again, I'll do it again. To start from point 0, 0, less than 0, which is at an angle of 0. Enter, that took me to the 0 point. So these are my values. These, as you can see now, the minute I enter these coordinates or these starting dimensions, the numbers appearing there in two different formats. I've got 2A22, that's a length, less than 46 degrees, 49 minutes and 54 seconds. That's an angle. Okay, so it's telling me you are currently drawing a line with these coordinates. That's not what we want. Let's go back here. What we want to draw is there we go. So we've got the length is 22 meters 995, and above it we've got the bearing value. So I'll enter these values. 22.995 less than or at an angle of 45 degrees. How do I enter this? 45D, that means degrees. 10 minutes, which is this symbol here, and you can obtain that from clicking on that. Okay, without any shift or anything like that. And then in a minute we will be using the seconds, which is the same button, but you have to press the shift key with it. Okay, so I'll go back here, 10 degrees and 30 seconds. Okay, again I press that shift here, that button here, which is shift and this button. So by doing this, enter, that drew the line correctly, but I can't see the line because my scale is too large. I'm zoomed out a lot. That's fine. Let's maybe then zoom, I'll scale this one down, maybe let's say 0.1, make it smaller, and zoom in here. To continue where I left off, so to continue, in fact, you know what? Let's do the right thing. Do you remember what we said last lecture? Let's scale this correctly. So very simply, I'll go scale, and from any point here, and R reference, I want from this point roughly, so we can get it the right scale. From this point to that point, I want it to be 22.175. Enter. There you go. Now we have it exactly the right scale, so at least we can look at it correctly. Okay, so that's the first segment we drew, that one there. If I need to go back to it, I just go to polyline, right click, and that will click to the last point I left off. All I did, chose polyline, right click, and that will click to the last point I left off. Or you can do that, that's fine, just starting from there. So continuing, our second line is 22.175 at an angle of 90 degrees, 15 minutes and 50 seconds. Enter. 20.09. Okay, so let's say okay, let's make a mistake on purpose. So 14, rather than 0.2, I click 142, okay? At an angle of, let's make a weird angle, let's say 30 degrees and 20 seconds, for example, and enter. Let's say I've done that, which is incorrect, okay? How can we fix it? Simply just, I'm looking at it here, Ctrl Z. That will take you to the previous point. And for any reason that you clicked out of this, or you drew something completely wrong, let's say that you drew that something completely wrong like that, and you clicked out, you can select that and go to the last point, hover over it. For some reason my computer is slowing down, and you can say remove vertex. That will remove the last point. Just hover over it. Okay? Okay, and to continue going back to where we at, again I'll just go to polyline, right click, that, okay, that clicked to the last point there, so I can't use that. What I have to do this time, repeat polyline, and I'll go myself and go to the end point where we left off, okay? And to continue with my drawing, I'm showing you just some common mistakes, guys, if they happen, how to deal with them. So we will continue. 14.2. There you have it. That's closed. So this is the actual shape of that. This is here what you can see on the screen here. By the way, so you can, if someone would say, well, this doesn't look exactly like that, that's correct, because look at this, I can switch this way or that way. It's just an image here. This is not accurate. This is an accurate drawing of that shape. Okay, so now I've got, because I've done a few stops and starts and I've got a few different segments now together, how can I connect them all together as a polyline? I select them all and just join. Okay, enter. If I select one, that will select all of them. One last important thing, that if you zoom in really hard into the endpoint, that you may find there's a small gap there. These two lines, they didn't close 100%. All the other lines, obviously they closed 100% because we did continue our drawing from each point to another. But this one last point here doesn't close 100% because that will be an error of the accuracy, because this could be 45 degrees, 10 minutes and 30.5 seconds, for example. But we're not really going down to that high level of accuracy. We may expect small error at the end for that shape. So there you have it. That's how we draw boundaries. For example, this could apply for a center line for a road, a pipeline, any other linear segments that we need to draw with polar information. But let's say this is a boundary, and you will learn later on how can I change this to a smart boundary. And when I'm saying smart, that means it does have the software is calculating bearing, calculating area, all of those components that we'll need for parcels or for a block of land. Later on we will learn this. You'll know exactly what I'm talking about. But to draw a parcel, which is the boundary, you will learn it later on. So I can create a parcel from an object. I created the object as a polyline. If I click on that and say change this to a parcel or a property boundaries, it's giving me some options here. What type of property it is, what side that you're working with. They're not very important. We will talk about them in details later on. And showing me what labels do you want to show. Do you want to erase the existing polyline after you drew the boundary? I'll just untick that for now. And okay, so it changed in color. The good thing about this thing in color, as I said, it's a smart boundary, because the minute I close it, look at that, if I zoom in and close it, that will straight away give me, this is property 1, because it's enclosed now, and I can get information about the area, about the parameter, all this units that we need. But that's not really what I want. What I want to show you is what we created, which is if I add labels for these segments, this segment here, that segment, that. First of all, these, they look messy and too big. So all I have to do is just change my scale. Let's change that to say 200, maybe 250. Bigger. There you have it. So look at these two, ignoring the last one, because remember the last one I changed it on purpose, ignoring that last segment. Look at all the other segments here. For example, let's take this segment 2218, which is, that's 22175, and I can change the accuracy for that to show me 175 if I wanted to. But more importantly, it's showing me the bearing. But the bearing, again, as you see and as we described in a different video, this is not the way we use it here in Australia. This is more the American way. It says from south to east, measure an angle of 89 degrees, 44 minutes and 10 seconds, and you get your bearing. But that's not what we do. What we usually do, as I showed you in the other videos, you go to your settings tab on your tool space, and if I go to the label settings and the line there for bearing, there you have it. So just to show you where we're at, we are in the setting tab. I'm going on the parcel because that is a parcel, and all the way to the line settings, bearing and distance. If I click on it and go edit, and what I'm interested of the bearing, and I need to fix that content of it. It's not the way that we want it to be. So I click here on that small box, which will open, it should open for some reason, a menu for me. As I said, my computer is slowing down. Okay, so that opened the menu I was referring to. The first thing I do, I delete what's in there. I'll show you again. So by clicking on that, when it opens the menu for me, it shows me this is the current content for the bearing segment. First of all, I select what's in here, delete that. Don't forget to delete that because I need to change it. and I go here to change them. The units is degrees, that's correct, and the format of that unit is degrees, minutes and seconds, that's fine. But instead of bearings here, we need to use what we call it north azimuth. North azimuth, that means we are measuring only from north. Okay, so north our starting point. And what precision we want to the nearest second, so I'll go to 1 second. That means degrees, minutes and seconds. And everything else shouldn't be a problem. Before you exit here, you haven't finished, don't forget to click on this arrow, because we deleted our settings. I need to add the new settings. Now I added the new settings, go OK and apply, and these, they should change. Look at them now. That's exactly what we had, 191550, and that's 191550. That's 133.16 and 30, 133.16 and 30. Alright guys, look, I'll stop here for now for this part of the video. I'll start a new one in a minute, but this shows you how do we draw a linear component for boundaries, road, center line, pipeline, any of those, and understanding the bearing components. What we call them the polar coordinates. Polar coordinates, that means they are made of two main things, length and an angle with the north direction. I'll see you in the next video.